Okay, welcome back to the third episode in our series on relational databases and relational database constraints. Let's get right to it. We've been talking about relations. Let's take a moment to review some terminology. When we were discussing domains, we said that a domain is a set of atomic values. The number of those values possible in a particular domain is referred to as cardinality. For example, the cardinality of the state domain would be 50. You'll recall that we said that a relation state is a relation with all of its contents or records at any given time, and that the relation state will vary as records are added and removed. Note the word valid here, as in valid tuples. Perhaps you'll recall in a previous lecture that a valid database state is a database containing records or tuples that comply with the data types and constraints specified in the various models. And finally, an attribute name indicates a role or a characteristic of an entity, such as age or first name. Why don't we talk about some characteristics of relations? The definition of a relation says it's a set of tuples. There is no order mentioned in that definition, so accordingly, tuples in a relation have no order. However, we are able to put a set of tuples of a relation in an order so as to make the relation state more understandable to the user or improve query response time. There are altered definitions that do refer to relations as ordered sets of tuples, but those are generally used to simplify notation. Values and nulls in the tuple. Each value in a tuple is an atomic value. That is, it's not divisible into components within the framework of the basic relational model. This model is sometimes called the flat relational model. Therefore, composite or multi-valued attributes are not allowed. For example, you cannot have an attribute called children that holds Tammy, Susie, and Ben. That would be multiple values for a single attribute. Not allowed in basic relational database theory. Much of the theory behind the relational model was developed with this assumption in mind, which is called the first normal form assumption. We're going to be talking about normalization in detail later. Null can mean either unknown value, values exist that do not apply, or the value is not defined. We'll talk about this later when we discuss foreign keys. Note that some relations may represent facts about entities, whereas other relations may represent facts about relationships. For example, the relation schema, description, design, so forth, relation schema, majors, open paren, student social security number, comma, department code, asserts that students major in academic disciplines. That's a relationship. A tuple in this relation relates a student to his or her discipline. Therefore, the relational model represents facts about both the entities, the student, and the relationships, majors, uniformly as relations. This sometimes compromises understandability because one has to guess whether a relation represents an entity type or a relationship type. For purposes of communication, our authors use the following conventions. The uppercase letters Q, R, and S denote relationship names. The lowercase letters Q, R, and S denote relationship states, or relations including the data at any given time. The lowercase letters T, U, and V denote tuples, or records. Generally, if you see the name of a relation, such as student, that also indicates the current set of tuples in that relation, or the current relation state. Whereas if you see student, open paren name, comma, ID, etc., close paren, that refers only to the schema, no tuples. An attribute can be qualified with the relation name to which it belongs using dot notation, relation.attribute. A real-world example would be student.gpa or student.ssn. We will discover the reason we might do this when we start writing queries and find that we're using the same name for an attribute in more than one table, which is not uncommon. For example, one can use the attribute name ID for entities in several tables. Then what do you do when you're creating a query using both tables and representing both IDs? The system has no way to process the query. However, if you use the notation in your query, table1.id and table2.id, you're good to go. For example, student.id and professor.id. Okay, let's take a break at this point. We haven't talked about a mystery word. We did discuss a little bit the idea of null values. So let's make null our mystery word for this episode. Go ahead, submit your mystery word, and then go to coursework to check your knowledge on the material we covered in this episode. And when you're ready, come on back and we will proceed to episode 4.